For around 100 years now we have been broadcasting wholesale electromagnetic radiation into the cosmos. The aliens on Eta Cephi, 70 light-years away, are relieved that TV broadcasts have just resumed after World War II and are now watching the first episode of Muffin the Mule, and Faraway Hill, and the first ever network televised soap opera. That is a nice simplistic idea, but is it actually true? Have we been the originating source of an alien wow signal for another civilization? The photons which comprise radio, and radar, which is typically orders of magnitude stronger, don't die off. They spread out. The question then becomes, could an advanced technology collect these photons and correlate them with a signal and then follow that signal back to the source? Can we imagine a way to do that? Assume time isn't a constraint and start with galactic dust. Using self-replicating technologies, assemble a significant portion into receivers. Spread these receivers over a large area. Since these receivers would presumably have to be powered, they would need a power source. A star would do nicely for a long-term power source, but would limit the size of the receiving array. With our Sun we can use solar energy out to Jupiter's orbit. That gives us a receiving array of approximately 2.0 x 10 superscript 2 cubic kilometers, give or take a few orders of magnitude. So yes, I would say it's likely that a sufficient number of photons could be collected. Could they be correlated with a signal? That would be a difficult problem. However, we can do it for a few hundreds or thousands of square meters of the collector. An advanced technology might be able to do the same thing with an arbitrarily large collector. Almost certainly an advanced technology would be better at picking likely targets for study. It's a question of signal to noise. There are some relatively simple equations that describe the signal-to-noise ratio of a modulated carrier. As a specific example, take a distant spacecraft like Pioneer 10 near the end of its life, traveling at more than 80 astronomical units from the Earth. The signal from its 8-watt transmitter was focused into a very tight beam by a 2.7-meter parabolic dish antenna, aimed at the Earth. Nonetheless, here on the Earth, reception required the use of a 70-meter antenna, combined with a receiver that was cooled to 3 degrees Kelvin, to receive a signal that was clear enough for a data transmission rate of 16 bits per second, with a reasonably low error rate. The limits here are fundamental limits of physics, not technology. The signal-to-noise ratio decreases with the square of the distance from the transmitter to the receiver, so with a receiver at interstellar distances, which would be many thousands of times farther than Pioneer 10, the S/n would be a fraction of a millionth of the S/n of the Pioneer 10 signal received here on the Earth. There are only 3 ways to compensate for this: a more powerful transmitter, a larger receiver antenna, and a receiver cooled to a lower temperature. The transmitter power is what it is. While our terrestrial broadcast stations are pretty powerful, their signals are not focused on parabolic dishes, so the effective transmitter power is, in fact, less than that of Pioneer 10's puny 8W transmitter. I don't think even an alien super civilization would build a dish antenna the size of a planet or larger, just to catch our broadcasts. That leaves the receiver temperature, but that won't work either, since, below 3K, we must consider that ever-present noise source, the cosmic microwave background at 2.7K. Which means that our receivers at NASA's Deep Space Network are already pretty much at the physical limits of what an ideal receiver can do. So is it dangerous? Nobody knows. What do we know? We listen and we don't hear anyone making radio noise nearby. I've read estimates that it will take upwards of X years to complete a full sky survey. Why don't we hear anything? Several potential answers spring to mind. There's nobody there. Since technology evolves, detectable radio waves are a short-term phenomenon for a civilization. Radio-emitting civilizations either destroy themselves or are quickly destroyed by an external force. Alien civilizations are keeping their heads down, either because of the preceding or just in case. But the question really doesn't end here. With our relatively primitive technology, we can now identify planets around nearby stars. We can envision technologies that will allow us to determine whether those planets harbor life or even a civilization. As our technology advances, the distance at which we can detect life and look for the markers of a civilization will increase. So given that we don't need radio waves to actually detect an alien civilization, it's likely an advanced civilization won't either. Given that fact, the fact that we're emitting radio waves like a vomiting teen on prom night probably doesn't matter.